In this video, we will get an introduction to statistics, which is the study, analysis, and interpretation of data. One way to analyze data is by finding a measure of central tendency. A measure of central tendency indicates the middle of a data set. The mean, median, and mode are the most common measures of central tendency. To find the mean of a set of data, we're going to add up all the data values and divide by the number of data values. To find the median, we're going to list the data values in order and find the number in the middle. If there are two numbers in the middle, as in this example, you'll take those two numbers in the middle and find their mean. So you'll add them together and divide by 2. And the mode is the number that shows up the most, or the most frequently occurring value in a data set. Sometimes a data set has more than one mode, and we call that bimodal. A bimodal data set has two modes. In this example right here, 3 shows up twice and 5 shows up twice. So both 3 and 5 are the modes. If there are more than 2 modes, it's probably not statistically useful. And if no value occurs more frequently than any other, then there is no mode. Let's take a look at an example. We're going to find the mean, median, and mode of this set of values. To find the mean, you're going to add up all the numbers and divide by the number of data values. The mean of this set of data values is 93.2. Also, another word for mean is average. Next, we're going to find the median of this data set. And to do that, we need to put the numbers in order from least to greatest. I've listed my numbers from least to greatest, and I know that I have 11 numbers. Since there's an odd number of numbers, there will be one number in the middle. And if I subtract that one number, that leaves 10. Divide that by 2, there's going to be 5 on each side of that middle number. So my middle number is going to be the 6th number in this list. 1, 2, 3, 4, 5, 6. It's that first 97. And notice there are 5 numbers on the left and 5 numbers on the right of that number. And that number is the median. Remember, if you have an even number of numbers, there will be 2 numbers in the middle, and you'll add those together and divide by 2 to find the median. And next, the mode is the number that shows up the most. And the mode of this data set is going to be 97 because it shows up twice. There are no other numbers in this list that show up more than once. So there's one mode and it's 97. In this data table, we are given the frequency that given data values occur. A weight of 2.3 occurred once, a weight of 2.4 grams occurred 4 times, 2.5 occurred once, and so on. So to find the mean, I could list all these data values. And as you can see, I wrote 2.4 4 times because it occurred 4 times. And 2.9 occurred twice, so I put 2.9s, and everything else occurred once. And then the sum of these frequencies are the total number of data values, and that adds up to 10, meaning there are 10 data values. This gives us a mean of 2.56. Another way that I could calculate the mean with frequency tables is to multiply the weight by the frequency. 2.3 occurred once, so 1 times 2.3 plus 2.4 occurred 4 times, so 4 2.4s, plus 1 times 2.5 plus 1 times 2.6 plus 1 times 2.8 plus 2 times 2.9 divided by 10. And that gives me that same answer of 2.56 for the mean. Now for the median, it's helpful to list the numbers or to at least figure out where the middle number would occur. Since I have 10 data values, I have an even number of data values, and if I divide that by 2, I get 5. So my fifth data value and my sixth are going to be my two middle numbers. And so if I look at my frequency table, since the numbers are listed in order, my first data value is 2.3, my next four are 2.4, and 2.4 would be my fifth data value. And my sixth would be the next one, 2.5. And since those are my two middle numbers for my median, I'm going to do 2.4 plus 2.5 divided by 2. If I had listed them all out, I would have seen that those are my two middle numbers, which I add together and divide by 2. And that gives us 2.45 for the median. And the mode, the one that shows up the most, well, 2.4 showed up 4 times, so the mode is 2.4. Another important vocabulary word to define is outlier. An outlier is a value that is substantially different from the rest of the data in a set. If the data is in one variable, outliers can occur at the ends. They can be misleading because they can affect measures of central tendency. So an outlier, a number that's way off the other numbers, can skew the data. Looking at problem number 2, we need to identify the outlier and then find the mean, median, and mode with the outlier and without it. Now, looking at those data values, the number 23 would be considered our outlier. Pause the video and find the mean, median, and mode with the outlier included in the data set, and then also find it with the outlier not included in the data set. When you're ready, unpause the video to check your work. If you compare the measures of central tendency, the median and mode didn't vary much when the outlier was included or not included, but the mean was significantly different. The mean with the outlier included was much lower than the mean with the outlier not included. So the outlier skewed the data and made it seem like the data was much lower than most of the data values actually were. Our next goal is going to be to make a box and whisker plot. But before we do that, we need to define a few more measures of data. The range of a set of data is the difference between the greatest and the least values. So I took the data from, I think the first problem we did, just to demonstrate. The range of this data, since these data values are already listed in order, is our greatest data value, 102, minus the least, 79, which equals 23. Now, if you order the data from least to greatest, the median divides the data into two parts. The median of each part divides the data further, and you have 4 parts in all. So if I divide this data into 2 parts, remember I had 11 data values, my 6th one was the median. If I take the lower half of the data values and I find the median of that set of data values, there are 5 numbers. The middle number is 87. I call that the first quartile. And then the median of the upper set of data values above the 97, above the median, there's 5 data values there as well, and the median of that set of data values is 99. We call that the third quartile. And the interquartile range is the difference between the third and first quartiles. And in this case, that would be 99 minus 87, which is 12. Using the minimum data value, the maximum data value, the first quartile, the median, and the third quartile, we can create a box and whisker plot, which is a way to display the values. The quartiles bound the center box, and the minimum and maximum values form the whiskers. To create a box and whisker plot, you have to list your data values from least to greatest, find the median, which is we find those middle two numbers, add them together, divide by 2, and obviously the median or the mean of 10 and 11 is 10.5. The first quartile is the median of the lower half of the numbers, which is 6, and the third quartile is the median of the upper half of the numbers, which is 15. The minimum value is 2, the maximum value is 32, and the range is the greatest value, the maximum minus the minimum, which is 30. If you like using technology to save time, here's a screenshot from Desmos. You can enter a list if you say L equals, or sometimes I say L1 equals, and then use a bracket and you just list the numbers. And they don't need to be in order, you just separate them by commas, and there is a bracket at the end of the list. We can't see all the numbers that I entered. It tells me how many elements are in my list, so I can make sure that I entered the right number of data values. And then if you go to functions and find statistics, you'll find mean, median, quartile, and other measures. So I showed how to find the mean. I found the median. And then if you want to do quartile, you choose quartile, and then in the parentheses you put L comma, and then I did 1 for the first quartile, which notice matches my Q1 over here. And for the third quartile, I did L comma 3, and that matches my third quartile. So that can save time to use technology. And now we're going to create our box and whisker. We need to label our scale on the bottom because this is a graph. So I think I can count by 2s on this graph. And I need to just make sure I include my minimum, my maximum, and all the numbers in between. And then for my median, I do kind of a large line. So my median is 10.5, which would be somewhere around here. And then I do the same size line for the first quartile and third quartile. My first quartile is 6. My third quartile is 15. And that creates my box. And then my minimum is going to be a little line at 2, the minimum value, and then a little line at the maximum value, 32. And then I connect those to the box to create the whiskers. And that's my box and whisker plot. So it sort of displays how the middle 50% of the data is clustered between 6 and 15. And we could see that the upper 25% of the data values are a little more spread out, and the lower 25% of the data values are more close together. So each part of this box and whisker plot represents 25% of the data values. And we can see how spread out they are. And finally, the last part of this lesson is percentile. Percentile is the number from 0 to 100 that you can associate with a value X from a data set. It shows the percent of the data that are less than or equal to X. If X is at the 63rd percentile, then 63% of the data are less than or equal to X. Find the values at the 20th and 80th percentiles for the following data sets. Well, in this set of data, first I need to list them in order. And now that they're in order, to find the number in that represents the 20th percentile, since there are 10 data values, the 20th percentile, I take 20%, which is 0.2, times 10, the number of data values, and I get 2, which means that the 20th percentile is the second data value. And in this case, that is 170. And for the 80th percentile, same process. I'm going to do 80% or 0.8 times 10, the 10 data values, and we get the 8th data value. And the 8th data value is 186. So the 80th percentile is 186.